Okay. So we're going to do 35. So it's similar to the last one we did, just a different scenario. So we have the mean is 1,850 grams. And we have standard deviation is 150 grams. So again, the mean is this number right here in the middle, 1850. Standard deviation is 150. So we add 150, and we get 2,000. And another 150, you get 2,150. And another 150, and we get 2,300. So that's to the right. We subtract 150. We subtract 150 again. And we subtract 150 again. And we get that. So this thing should be symmetric around. So we have 400 to 850, that's 450, and 1850 to 2300 is 450. So that's good. It's 3 times 150. Okay, so those are good. So now the question is, for 35, it wants it between the percent. So it's just asking for percentage, so we don't have to multiply by anything. We just have to come up with a number. Between 1750 and 1900 grams. So let's draw those as vertical lines on our graph. So here's 1700, here's 1850, so it's about a third of the way between those two. So that's one side, and then you have 1900. So 1850, 2000, 1900 is about right there. And what we're looking for is the area between these two vertical lines. So since we are straddling the mean, what we can do is basically do each one separately. We can find the blue area, and this is where we add them together, and we have the green area. And then you just add the red is the blue plus the green. Now again, because of symmetry, we'll have a negative z-score here, but we can look up the area associated with the corresponding positive z-score. So let's calculate the z-scores for these two values. So the z-score is the value at that particular point, and then you subtract 1850, you divide by the standard deviation, which is going to be negative 100 over 150, which is negative 0.666, round up to 0.67. And then the z-score associated with 1900 is going to be 1900 minus the mean divided by the standard deviation. So it's positive. It's going to be positive 50 over 150, which is equal to positive 0.33. So we round down 0.333333 is just 0.33. Okay, so now we just have to look up the corresponding areas associated with these two z-scores. But actually what we're going to use is the positive value here. So what we can say really is that the area associated with z equals negative 0.67 is the same as the area associated with z equals positive 0.67. So we go to the table, second row, second column, 0.67 is 0.249. So this is 0.249. So 24.9% of the area is between here and there. Then you can do the area of the z-score on the second side with z equal to 0.33. And we don't have to do anything, it's already positive. So we go to the first column, look down at 0.33, and the z column at 0.129. So 12.9% are here, and therefore the total area, so area total is going to be a sum of these two, 0.249 plus, excuse me, 0.1929, 0.249 plus 0.129 is 0.378, or the problem asked percent. So therefore 37.8% of the chickens weigh between 1,750 grams and 1,900 grams. So that's problem number 35. Okay, so now we're going to 38. So 38 is cereal boxes. It said a certain dry cereal is packaged in 24-ounce boxes. The machine that fills the boxes is set so that on average, so the average is 24.5 ounces. The machine-filled boxes have content weights that can be closely approximated by a normal curve. What percentage of the boxes will be underweight if the standard deviation is as follows? So we're going to use S equals, we're doing 38, which is 0.4 ounces. So what you're going to do is you're going to, if I draw a line, let's find the z-score equal to, well, that is, well, the z-score here, this is, let's see, the standard deviation. Okay, yes, I remember what it is. Okay, so what we're looking for is where x is equal to 24 ounces, because that's the target. So we set the target. This is the minimum that we want to ship, and this is the target. So you always have to shoot higher because you get some variation around this target, and you want to make sure that works out. So what you do is you find the z-score associated with x equals 24. So you get 24 minus 24.5 divided by the mean, which is 0.4. So that's negative 0.5 over 0.4, and that is going to be negative 1.25. So that's the z-score. So let me just draw a vertical line. So negative 1.25. And what it's asking is what percentage is going to be underweight. So that is what we're talking about. So if this number, let's just put it in here, if this is 24.5 and the standard deviation is 0.4, we're going to get 24.1, 23.7, and 23.3. So there's a 0.4 difference between each one of those. And you can go the other direction, 24 point, add 4, so 24.9, 25.3, and 25.7. So each difference between each one of these should be 0.4. Okay, so we're looking at the minimum that we want to ship, what we consider to be acceptable, to be 24. And you see there's 23.7, there's 20, so it comes out right here. So now that we have drawn this we've had these before where we've got this part that's out by itself. It's not touching the mean in any way. So we have to find the area, the blue area, which consists of everything to the left of the median, and then we can do the green, which is everything to from the left of the mean to the z-score there. So remember, the area, the blue area is 0.5 because half of the data is less than the mean. The green is going to be a function of the z-score. So the area, the green area, is a function of z equal negative 1.25. But that's the same as the area associated with the z equals positive 1.25. So we can use the table. So we go with that z-score to the table on 671. We go down. It's the third column of set. And 1.25, we get 0.394. So this is 0.394. So the red area is going to be equal to the blue area minus the green area. But the blue area is 0.5, and the green area is 0.394. You take that difference, 0.5 minus 0.394, which is 0.106. So that's the difference, which is the red area, 0.106, or 10.6% will be, what's the word they call it? They call it the, let's just read it. Certain dry cereals packaged in 24-ounce boxes. Underweight. Okay, so the answer is 10.6% will be underweight. That's what that's supposed to say, underweight. Okay, we have two more problems, 56 and 57. So let's see what that is. So it says a normal distribution has a mean of 76.8, standard deviation 9.42. Use the method in example 6 and find the data values corresponding to the defining values of z around to the nearest tenth. So that seems pretty easy. So just like there's got to be something wrong. It's too easy. So what we have is x bar is equal to 76.8. We have the standard deviation, which is s is 9.42, and so really all you do is use the definition of the z-score to solve for x. So that's the formula, and if you multiply both sides by s, you'll get z times s is equal to x minus x bar, and then we add x bar to both sides, so we get that the value is equal to x bar plus 2, that's not 2, that's z. So I'll change the order, sz, s times z. So knowing that, all we have to do is 56. We are given z is 0.72. So the value is, the mean value is 76.8 plus s, which is 9.42 times z, which is 0.72. And since z is positive, we should be more than the mean. 76.8 plus 9.42 times 0.72 is 83.6, which is the answer. Okay, and then we do the same thing for the next one. Z equals 1.4. So you get x, the corresponding x value is 76.8 plus 9.42, the standard deviation times z, and you get x is equal to 90.4.